Here, to integer 123, we find GCD. Okay, so R1 is like a and B. Okay, so this R1 and this R2. In algorithm, we learn AB is assumed like R1 and B is assumed R2. So here R1 value is 100 and R2 value is 23. So for a finding extended Euclidean, first of all we draw the we make a table like Q1 Q R1 R2 R T1 T2 and T. So R1 value is 100 and R2 value is 23. So in algorithm we will learn Q is R1 by R2. So Q is R1 by R2. So 100 by 23. So we get 4. In this we write positive integer, real integer. Okay? Not write point value. Then R. For R1 minus Q R2. So R1 is 100 and Q is 4 and R2 is 23. So we get 8. And T1 and T2 in algorithm we assume T1 is 0 and T2 is 1. So here T1 is 0 and T2 is 1 and T is T1 minus Q T2. So T1 is 0 minus Q is 4 and T2 is 1. So minus 4. Then in algorithm we learn R2 is replaced by R1, R is replaced by R2. So we perform those steps. R2 is replaced by R1. So R1 is 23 now. R is replaced by R2. So it is R2. And T2 is replaced by T1 and T is replaced by T2. Now we find Q, R and T. So Q is R1 by R2. So this time our R1 is 23 and 8. So 23 by 8. 23 by 8. So we get 2. And R is R1 minus Q R2. So R1 is 23 minus Q is 2. So 2 and R2 is 8. So 23 minus 2 8. So 23 minus 16. So we get 7. And same T. So T1 minus Q R2. So T1 is 1, Q2 and T2. T2 is minus 4. So 9. So 9. Then replacement. Same. So R2 is replaced by R1 and R is replaced by R2. And T2 is replaced by T1 and T is replaced by T2. So Q. Then 8 by 7 we get Q value is 1. Then R. So for R1 minus Q R2. So 8 minus 7. So 1. And T1 minus Q R2 minus 4 into Q 1 and minus 9. So we get minus 13. Then same steps. R2 is replaced by R1, R replaced by R2. So 7 and 1. Then T2 is replaced by T1 and RT is replaced by T2. So 7 by 1 is Q, we get 1. 7 minus 7, so 0. And 13 we get 100. So in this R value we get 7. So now we not perform in so because we get this replace. So R2 is R1 and 0. So R2 is 0. So R1 by R2, so 1 by 0. So in we not a step of perform. So okay, so that's it. So our GCD is R1. So R1 value is 1. So GCD is 1. And minus 13 is equals 90 and 100. So we get GCD value is 1.